So physical characteristics. So one of the physical characteristics here it is this is to determine the physical method analysis. With the help of the physical method analysis, we can detect it. The one is the color. Okay. So one of the physical characteristics it is the color. Now we easily with the neck eye we can easily find out whether the waste water, what is the quality of water, the water, what is the quality of that water. The one is on the basis of the color. If it is you found a grayish brown or yellowish color, okay, so it indicates that it is a fresh sewage. Fresh sewage means if you talk about the sewage one, so let's if the color is grayish brown or the yellowish one, then we can say freshly the effluent comes in into the ETP plant. Okay, and as the time goes, the color from the grayish brown or to the yellowish, it is converted to the black. Now, why? What is the reason behind it? Why the color of the sewage, which is initially when it is come out from the plant and it is drained into the ETP plant, and there is a the color it is showing around about it is yellowish one, and then afterward, after a few the few hours or once the time goes on, then it is find that the color change from the yellowish to the black. The reason behind is that the reaction taking place. What are the reactions going on in that sewage? So obviously the one is the aerobic and the anaerobic. The waste which is come out from the plant, it may be the organic one or it may be the inorganic. If it is the organic one, in that case the decomposition start. And once the decomposition start, the oxygen which is dissolved in the sewage on that waste, it get consumed by the microorganisms. The microorganisms which are helping to decomposing that are consuming. And what happened one time come that there is no oxygen available in the waste, and when that condition is appeared, then what happened, the reverse reaction is goes on. In that case there is a anaerobic reaction going on, and as because of the anaerobic one, it is a color, it may be the change from the yellowish to the black one. Okay, so this is the one of the reasons that we can say that how the color is give the indication of the waste it is. Okay, so this is the one of the method that we can find out. So the color of the sewage can be normally detected by the eyes. So if you see in this picture, from this one we can easily say that yes, this is a dirty water, or this is the water which is not for the drinking purpose or for the irrigation purpose. Why? Because if you see here the color of the discharge water, it is a yellowish color, and this is in a pink, reddish pink color. Okay, so from that one we are not drinking such type of the water, or we cannot use such type of the water in the process industries. So we can easily detect with the help of the naked eye. Okay. So this is the one of the characteristics, the color. Second one, it is odor. Now this is also the one of the indication, just like we use the eyes for detecting the whether the what are the on the basis of the color we can easily detect whether it is usable or non-usable water it is. Now the odor is also one of the physical characteristics here. So what happen in odor? Odor of a fresh sewage is not offensive. If the sewage comes, fresh sewage comes from the industry, so it will not say that much odor. You will not get that much odor, but once the time passes, then it gets start decomposition, and once it is start the decomposition, the smell it is around that plant it get. So what is that? Fresh sewage is not offensive, or practically it can be considered the odorless, but as it is started to get stale, it begins to offensive odor. Okay, so within a 3 to 4 hours all the oxygen present in the sewage get exhausted, and there is a formation of the hydrogen sulfide gas, and which is give the odor. Okay, so that is the one of the reason that why there is odor. So initially when the sewage comes out from the industry, from the process plant, it having the fresh one, there is no smell around that plant, but as the time passes, then it gets started to smelling, and just because of the formation of this hydrogen sulfide gas. So as H2S gas is formed, there is a offensive odor you found around the plant. So this is one of the indicator that whether what is the characteristics of the sewage. The another thing is in the wastewater, it is the turbidity. Now, what is this turbidity? The turbidity is what it is, the amount of solid material present into the water bodies. So it may be the dissolved solid or it may be the undissolved or suspended solids. And mostly because of the suspended solid, because of the high concentration of the solid which are present in the wastewater, and that indicates the turbidity of the water. So the one thing, obviously, for that one, either we can see by the naked eye, okay, what is the does the wastewater it having the turbide or not, or we have the different instrument that we can use, just like the example is the nephelometer. Okay, so this nephelometer it can be easily indicate whether the what is the turbidity of the water, and accordingly we can characterize the wastewater. Okay, so sewage it is normally having the turbide. So dirty water is dirt is present in that wastewater, and because of that one, the formation of the water it get polluted one, or we say high turbide water. So turbidity is depend on the quantity of the solid matter present in the suspension state. So obviously we can say that as the what is the concentration of the solid matter present in the water, accordingly we can decide what is the turbidity of the water. So obviously here the example is the nephelometer is one of the instrument that can use to detect the turbidity of the water. And if you see that already we done that experiment in the virtual lab, and we have the nephelometer, what are the chemicals we needed, and how the samples we are we just use the samples, and on that basis we can find what is the turbidity. So this nephelometer is work on the basis of the how the light gets scattered, and that light gets scattered on the basis of the concentration of the solid material present in it. So this is also the one of the physical characteristics of the waste. If you see here, from this picture, you can easily say that it having the high amount of the suspended or the dissolved solid present in these water bodies. If you see, this is also the one of the waste generated from the factory, and you see here again with the help of the color and the suspended solid, we can easily say that this is the water having the high or we can say high turbide water. These two pictures it show the one picture it shows that is the turbidity the solid material present and the high turbidity here, and it having the low turbidity because of the all the solid matter which are dissolved or suspended here, it gets settled down, and now the clean water you get at the topmost and the settled particles at the bottom. But this picture it show the high turbide water. Okay, so either, but we don't know. We can say that by the naked eye that yes, it is the turbide or a high suspended solid present in it, but we don't know what is the quantity of it, because when you are designing a plant or when you are doing an experiment, that time definitely we should know what is the value, what is the value, and that can be calculate or we can find out with the help of the instrument or with the help of the chemical test on it. Okay. Now, another the physical characteristics that we have a total solid. Just like I said, turbidity we are decided on the basis of how much is the solid matter present in it. Now, what do you mean by total solid? What is mean by dissolved solid? And what is mean by suspended solid? Okay, so this is very interesting that when the word comes the solid, okay, in the wastewater or in the environmental engineering, what is the meaning of the total solid? So, total solid we can say it is a combination of, let's see first what is total solid. It is a combination of the suspended solid and the dissolved solid. In latter word we will see about what is the dissolved solid and what is the suspended solid. So here we can say a total dissolved and the suspended organic or inorganic residues which is left after the evaporation is expressed in milligram per liter, and that will give the total solid. So total solid it is the addition of the dissolved solid and the suspended solid. So okay, so this total solids obviously it contains both the dissolved solid and suspended solid. So suspended solids, obviously it is include the both the non-settleable and settleable material. We can easily distinguish this one in the given in the in the next slide figure, that how what exactly the suspended solid mean and what exactly the the dissolved solid, and in a suspended solid how we can distinguish settleable and non-settleable one. Okay. So if you see the concentration of the solid, most of the times we can say if it is above the 720 degree, sorry, 720 milligram per liter, the total solid, then we can say it is harming for the drinking purpose. And for that one, we need to treat that water, and we have to reduce the suspended solid or the dissolved solid present in it. Just like when we want to buy a filter for our home, okay, and for that one we always check the TDS. TDS is what? The one TDS it is related to the finance, and one TDS is related to the environmental engineering, and we are talking about the environmental engineering. Okay, so what is TDS? TDS is the total dissolved solid. We always try to find what is the dissolved solid present in it. Though we cannot see, but yes, the solids are present, and with the help of the instrument, we always check before we are choosing the which type of the filter that we need to place in our home. We always check the TDS. Okay, that is TDS what? Dissolved solids. And what is the range, and on that basis we will decide whether we are go for the RO, the reverse osmosis technology, the membrane filter, so that whatever be the excess TDS which are present in the water, it can be filtered out, because we need to filter that the dissolved solid present in the water bodies, so that it will not harm to the human bodies. Okay, so with the help of this diagram we can easily understood what exactly the meaning of it. Okay. So this picture it shows the one line. It is what is the total solid, and they are divided as we divided the total solid in the dissolved solid and suspended solid. So this portion we can say this is a dissolved solids, okay, and this line up to this one we can say it is a suspended solid. So total solid it is the addition of the dissolved solid and the suspended solid. So that is the total dissolved solid. Now we can divide the suspended solid as we say the non-settleable and settleable one. If you see the colloidal solid or the colloidal material which is present in it, it is a non-settleable, and some of the material it gets settled down. So just like if we perform the experiment and we want to settle down the solid, so after a few times with the help of the alum or other the chemicals we can add, and it can be dissolved solid, it can be easily settleable. Okay, so that is what settleable. But some of the colloidal materials is not settled, and that is though it is a suspended one, but it is not settled down. Okay, so we can divide the suspended as a colloidal solid plus settleable solid. Okay, and this is the range I'll mention. What is the range? If the total solid it having the 720 milligram per liter, then it the dissolved solid it having the maximum one around 5,500, and the suspended one around 220. Okay, if you take the ratio of these two, then you will find the more dissolved solid is present and the less one a suspended solid present in it. Okay, now let's talk about the dissolved solid. Already I said what is dissolved solid. It is the solid which will pass through the standard glass fiber filter. It is in a dissolved form. Okay, so once it is passed through the standard glass fiber filter, then that type of the solids we can say it is a dissolved solid. So solids weight is difference in weight between the total solid and suspended solids. So how we can find out the dissolved solid? If we know the total solid, and if I minus the suspended solid, then I can get the quantity of the dissolved solid. So let's see here when the sample of the filter through the fine mesh filter, for example 0.45 micron membrane filter that can be used, the suspended solid are captured on the filter. Now another method is what? If we have a membrane which having the 0.45 micron size, and if we pass that solution through this membrane, then what happen? The particles are accumulated or captured on the screen, and that filter we can and the dissolved solid will remain in the water passing through the filter. So what happen? If we have a membrane filter, then a suspended solid which is present, it can be easily captured on the membrane, and the dissolved solid get passes through it, because the size of the dissolved solid is less than 0.45 micron. Okay, and because of that one we can easily take out the sample, that is suspended solid, and from that one we can say yes, this is the amount of the dissolved solid present. So we can easily determine the weight of the solid sample, the water that passes through the filter. Then we have to evaporate that sample. How we can know what is the dissolved solid present? First what we do, we take a sample, we filter out with the help of the membrane, and the suspended solid which is captured on the screen and the dissolved solid are moving with the water bodies. Now the dissolved solid we can easily find out if we evaporate the water sample. So this water sample which is having the dissolved solids, we have to evaporate that one, and the remaining residues that will give the dissolved solid present in the water. Okay. So mostly the concentration of this dissolved solid is 500 milligram per liter in the water sample. Now, what is suspended solid? The suspended solid is what? As I said, the material which are captured on the screen. So we use the point 0.5, mostly the 0.45 micron size filter, and the solid which are captured on that filter pad, that will we have to weight it, and from that one we can easily know what is the suspended solid. So once we know the quantity of the suspended solid and the quantity of the dissolved solid, addition of the suspended and the addition of the addition of the suspended and dissolved, that will give the total solid present in the water samples. Okay. So what about then now this is one in the suspended one, we say that the material is settleable and non-settleable. What is the what happened? Those who are lighter in weight. So that is solid which will be settle or the float in the clarifier, and the lighter non-settleable solids, or we call it is the colloids. So if you see the suspended solid concentration in the water bodies, it is around 20 to 20 milligram per liter. Now this is from the diagram. We are not stick with this one, but yes, this is the minimum range that can be, we can use it, that water. But if it is the range is above, then it will be the we need to treat that water. Okay, on the basis of we find out what is the total solid present in it, and on that basis we will use the unit operations. We will use the process, which type of the process that we need to use here. Just like I would like to give the example as if you want to this is all about physical characteristics where we determine to know the primary treatment. What are the primary treatment? In the next chapter we will look about the primary, secondary and tertiary treatment. Okay. Now for the primary treatment we should know what is the physical characteristics of the waste which is generated, which is comes out from the plant. Now if it having the more colloidal particles present in it, then in that case what we do, we are using such type of the unit operation which only float the colloidal particles, because it is not settleable easily. Either we can use certain alum or certain chemicals so that it can be settled down, or we use the floating process. Floating means the aeration one. From the bottom side we have to just aerate it, and the colloidal matters is floated on it. Okay, and on that basis we can remove the colloidal particles easily. Or those who are a suspended one and easily settleable, for that one we can use the column, settling column, or the clarifier or the thickener, which can be settled down the settling particles. Okay, so these are the unit operations or the processes that we are used to separate out the things. For that one definitely we need to know the physical characteristics of it. Same thing for the turbidity, we can easily say that if this is the turbidity, then which of the unit operations that I need to use. If there is a odor and color, on the basis of that one also we can use the certain adsorbent which can be adsorbent or the absorbent which can be absorb the color as well as the odor from it. It can extract the odor from it. Okay, so that the physical treatments that we need to give before we need to send it to the secondary treatment. Okay, so this is very important. All the matters need to capture it initial stage in the physical one. Okay, so this is all about the physical characteristics. Same thing for the inorganic organic one. We have given the treatment and we determine what is the alkylity, how much is the inorganic matter present in it, what type of the metal it is, and on that basis we will decide whether we have to go for the biological treatment or we have to go for the chemical treatment. Okay, all these things is very important to determine the organic, inorganic and the physical characteristics so that we can give a proper treatment for it. Okay, so this is all about the physical characteristics and the determination of the organic and the inorganic matter present in the wastewater, and this is the important for giving a treatment for the that particular